the further pure 2021 May-June paper 13. Let's take a look at the question number 1 over here. A. Show that tangent r plus 1 minus tangent r is equal to the sine 1 divided by the cos r plus 1 multiplied by cos r. So what we can do over here is we need to join them together by splitting the tangent to become sine r plus 1 over the cos r plus 1 minus the sine r divided by cos r. So you just combine them, become one fractions, then you will get sine r plus 1 cos r minus the cos r plus 1 sine r divided by the cos r plus 1 cos r. Okay, so this is what you're supposed to have. Then for your numerator, we can actually apply the compound angle. We can apply the compound angle formula. Then you will get this as the sine of r plus 1 minus r divided by the cos r plus 1 cos r. So at the end, you will get this result. Shown. Okay, so this is how you get the answer for the number 1. A. Now we move on to the number 1B. It's a series. The question's giving you that the UR look like this, and they want you to find the sum of the UR from to the n terms. So we just need to change the UR into this. So you know that you need to make use of the result in part A. But just now the part A, our numerator is not 1. Just now our part A, our numerator is a sine 1. So we just write this one out. And this will be 1 over sine 1. Then if we use a result in part A, you can actually break them become tangent r plus 1 minus the tangent r. Okay, then all you need to do is just to substitute the value. Inside, you have a tangent 2 minus a tangent 1 plus the tangent 3 minus a tangent 2, tangent 4 minus the tangent 3. And up to here, you can see the pattern that these two can be cancelled off. These two can be cancelled off. And the pattern will behave in this way until you go to the last two terms. That will be tangent of n plus 1 minus a tangent n. This will be the tangent of n minus of tangent of n minus 1. So you can see that this also can be cancelled, which means anything in between also can cancel in such a way. So at the end, you have this will be 1 over sine A1, then a tangent of n plus 1 minus the tangent 1. This will be the answer. Of course, you can choose to multiply them inside as a above here as a numerator, and you can simplify them in such a way. Done. This will be the answer for the question number 1B. And now move on to the 1C. They want you to explain why the infinite series for the U1, U2 plus U3 does not converge. So you just need to mention that when the n goes to infinity, your tangent of n plus 1 is actually fluctuates between negative infinity to infinity. Okay. So you can see that the answer over here is very dependent on the n. Okay. So you just say that because as the n approaches to infinity, your t of n plus 1, it fluctuates between negative infinity to infinity. So therefore, the series, infinite series, UR, does not converge. Okay, that is the answer for the question number 1C. And now move on, we have a question number 2. A cubic equation and has a root of alpha, beta, gamma. And they say that let alpha power n plus beta power n plus gamma power n as a Sn. We want to find S1. So S1 is actually alpha plus beta plus gamma, which is actually a negative of negative 4 divided 2. It is a 2. Then S2 is alpha square plus beta square plus gamma square. The formula for this one is alpha plus beta plus gamma square minus of this. So this will be 2 square minus the 2 times 0. You get a 4. Okay, that will be the answer for number 2A. Now we move on to the 2B. They want you to express Sn plus 3 in terms of Sn plus 2 and Sn. So right here, we just need to, from the expressions over here, from the cubic equation given, they become 2x3 equal to the 4x squared minus 3. And you multiply everyone by x power n. Okay. So if you multiply everyone by x power n, then you will get 2x power n plus 3 equal to the 4x power n plus 2 minus the 3 of x power n. And you will get 2n Sn plus 3 equal to the 4Sn plus 2 minus the 3Sn. But we cannot stop here because we are looking for Sn plus 3, which is a 2Sn plus 2 minus a 3 over 2Sn. Done for the part B part 1. Now we want to go for the B part 2. We want to find S4. So from the answer over here to find S4, you just need to let your n equal to 1. Then you can get S4 equal to the 2S3 minus a 3 over 2S1. You already have this value, but you do not have this value yet. So I need to find S3 first before I find the S4. So to find the S3, I need to let my n equal to 0. Then I can only find the S3. So we'll solve it over here. We just write down here when n equal to 0. So you have S3 is equal to the 2S2 minus the 3 over 2S0. So from part A just now, we know S2 is a 4. Then this one is a 3. 8 minus 9 over 2. 8 minus 9 over 2, you get 7 over 2. So when n is equal is 1, you get S4 equal to the 2S3 minus the 3 over 2 of S1. So you just substitute the value inside. S1 in part A we also have is a 2. So it's a 7 minus 3 is a 4. Done. This will be the answer for the number 2B part 2. Now we move on to the 2B part 3. Using the substitutions. So your y is equals to the S1. S1 is a 2 just now. So it will give you x is equal to 2 minus y. So from the equation 2x cubed minus a 4x squared plus 3 equal to 0. Change all your x become 2 minus y. Expand them carefully. Then you will get this 8 minus the 12y plus the 6y square minus a y cube minus 4 minus 4y plus a y square plus a 3 equal to 0. So you get 16 minus 24y plus 12y square minus the 2y cube minus a 16 plus the 16y minus a 4y square plus 3 equal to 0. The highest power is y power 3. And we want to make the y power 3 positive. So you get 2y cubed minus the 8y square plus the 8y minus the 3. Equal to 0. So this will be the answer for the question number 2C. Okay, so we have done it. Then we are looking for the D. D is to find the 1 over alpha plus 1, 1 over beta plus 1, and 1 over gamma plus 1. So we know that the root over here, it will be alpha plus beta, alpha plus gamma, and beta plus gamma. Okay, so we know the root is over here like this, root for the y. So then over here, we just need to take these equations, minus the 8y square plus the 8y minus the 3. I divide everyone by y cube, and I get 2 minus the 8 over y plus the 8 over y square minus the 3 over the y cube. And I rearrange it in this way. The root is alpha plus beta, alpha plus gamma, and beta plus gamma. Then the equations over here, the root will be 1 over alpha plus beta, 1 over alpha plus gamma, and 1 over beta plus gamma. So therefore, your 1 over alpha plus beta plus the 1 over beta plus gamma plus 1 over alpha plus gamma is actually equals to the negative of negative 8 over 3. That will be a positive 8 over 3. Done. This will be the answer for the question number 2D. And move on, we have question number 3. Now we want to prove by mathematical induction that this relationship is true. So to prove by mathematical induction, we will start from n equal to 1. So you will get my apologies, this is a typing error. Your R supposed to start from 1, not start from 2. Okay, sorry for that. So this one is a typing error. R equal to 1. So we start from R equal to 1. Then you will get 1 to 1, 5R power 4 plus R square. It's a 5 plus 1 is a 6. N is equal to the half of 1 square, 2 square, and 3. It's the same. So your left hand and right hand are tally. True for n equal to 1. And now we assume true for n equal to k, which means that the sum from r equal to 1 to k over 5r power 4 plus r square is actually can be represented by the half k square, k plus 1 square, and 2k plus 1. So we need to consider the case when the n is equal to k plus 1. That means is we need to sum over here like this. Which is on top of the 5r power 4 plus r square. Then you plus another extra term, which is a 5k plus 1 power 4 plus the k plus 1 square. So you just copy this result over here, you will get half k square, k plus 1 square to k plus 1. Then copy down this. You can see that the three terms over here, they all have a common factor of k plus 1 square. So I factorize the k plus 1 square out. Over here, I have a k square to k plus 1 plus the 10 of a k plus 1 square plus 2. Expand and simplify the last expressions over here. You will get 2k cubed plus the 11k square plus the 20k and plus a 12. Then try to factorize it. You can see that we can factorize the 2k plus 3 out. How do we know that we can factorize 2k plus 3 out? Well, actually, you can, because our target is to show this k plus 3. We know that our target will be this. So we are expecting our last part of the expressions over here will be the product of k plus 2 square multiplied by 2k plus 3. So we can know like that. Then we have a k square plus 4k plus 4. So this is a k plus 2 square multiplied by 2k plus 3. Basically done already. You can just say that true for n equal to k plus 1. So therefore, by the BMI, the series over here of 5r power 4 plus r square, where the r is equal to 1 until n is equal to half n square, n plus 1 square, 2n plus 1. For all positive integers n. Okay, to be more complete. So this will be the answer for the question number 3a. Now move on, we have a 3b. They want you to use the formula booklet, MF19, to find the sum of r power 4 and factorize a fully factorized form. So from A, we know that from A, we already know this result. Okay, so if you use formula booklet, that means I have to expand the left-hand side, make it become 2 series. And one of the series is we use a formula booklet to find the answer. So it will be 5 of the sum of the r power 4. This will be the formula booklet, n plus 1, 2n plus 1 divided by 6 is equals to the half n square, n plus 1 square, and 2n plus 1. So your left-hand side will still remain of the sum of r power 4, and then your right-hand side will become this. Then you can see that your right-hand side actually have some common factor that can be factorized out. So we factorize 1 over 6, n plus 1, and 2n plus 1 out. Then I get n plus 1 minus the 6. Then you expand and simplify. You have a n plus 1, 2n plus 1, n squared plus n minus 6. My apologies. There's a 3 here. Because I factorize 1 over 6 out. This is a 1 and this is a 3. Okay, so you expand, simplify, you get a 3n squared plus 3n minus 1. This is the answer in the fully factorized form. But I need to find the r power 4. So which means the 5 need to go to the other side. 5, I divide 5, then you will get 1 over 30. Okay, so this will be the answer for the question number 3b. Move on. We have a 4, question number 4. Matrices over here, A, B, C as given. They want you to find the product C, A, B. So the C, A, B, if you write them out, the C will be a 0, negative 1, 1, 2, 1, 0. A will be a 2, 5, 1, K, negative 1, 0, K, 3, 1, multiplied by the B, 1, 0, 1, 0, 1, 0. So you can actually multiply AB first and then multiply by C later, or you can multiply CA first and then multiply by the B later. Over here, I will multiply the AB first. Okay, so I will multiply these two first. Then you can see that it will be like this, 2 plus K, 8, and then 2. Then K minus 1, 0. Then after that, you multiply with the C, then you will get 10, negative 1, negative K plus 14, and minus K minus 2. Done. This will be the answer for number 4A. Now we move on to 4B. They mentioned that the A is singular. A is a singular means the determinant A is a 0. So it will be 2KK, 5, negative 1, negative 3, and the 1, 0, 1. So you get 2, negative 1, minus K of 5 plus 3. Sorry, I copied wrongly. The A should be positive 3, not negative 3. So this is the positive 3. Then this one, it will be a minus 3. Then after that, we will have a K, which is a 1, equal to 0. So at the end, you get negative 2 minus 2K plus K equal to 0. And then you get K is a negative 2. Done for the B. Now we move to the C. Using the value of K from the part B, which is the K equal to negative 2. We want to find the equations of invariant line for the CAB. So your CAB now will look like, replace K equal to negative 2 inside. Then you can get the CAB is a 10, 16, negative 1, 0. So invariant line, your image line, object line will become your image line. So it will be like this, x, mx, then you will get x prime, mx prime. And this matrix is a CAB. So you get 10 minus m. Then you get the 16x is equal to the mx prime. That is your equation 1. That is your equation 2. Solve them. 1 divide 2. You get 10 minus m divided by 16 is equal to 1 over m. 10m minus a m square equal to 16. M square minus a 10m plus 16 equal to 0. M minus the 8. M minus a 2. So your m is equal to 8 and 2. Therefore, your invariant lines will be y equals to 8x and y equal to the 2x. You have two invariant lines over here. Okay, So this will be the answer for the question number 4C. Moving on, we have a question number 5. It's between 0 to half pi. We want to sketch the graph of the C. So for these questions, usually we just need to draw a table and calculate the value by using calculator. So we start from 0, then pi over 6, pi over 4, pi over 3, and then pi over 2. So if you use a calculator, you can see that we just press it, maybe just 1 or 2 decimal places, as long as it's enough for us to roughly estimate the locations, that will do. So this one, it will be the value that I have calculated earlier. So what you can do here is on the space given, you just need to draw the diagram carefully. Theta equal to 0, theta equal to pi over 2 here. This is the pi over 4. Then this is the pi over 6. Then this one is the pi over 3. So just plot the point starting from 0, pi over 6, pi over 4, then pi over 3, and here. So you can see that your graph will be somewhere like this. Okay, because I didn't draw with a proper scale, so my graph may not look exactly the same. Okay, however, you can refer to the mark scheme for the actual graph. Your graph will look something like this. So this will be the graph for the question number 5A. Now we move on to the B. We want to find the area of the region, and to show that the area of the region bounded by the curve and the theta equal to the pi over 2 is in this form. Okay, so we are looking for this area over here. So for finding the area over here, we just need to integrate the theta from 0 to pi over 2. So the formula for area is half r squared d theta from 0 to pi over 2. And the r is 1 over the pi minus theta minus 1 over pi squared d theta. So what you can do over here is just to expand them. Expand the bracket, then you get this square minus the 2 pi minus theta plus 1 over pi square d theta. So if you integrate them, this one it will be 1 over pi minus theta. This one will be a 2 pi ln, that's plus here, pi minus theta, then plus the 1 over pi square theta from 0 to pi over 2. Substitute the pi over 2 inside, then you will get this one as a 2 over pi plus the 2 pi ln pi over 2 plus the 1 over 2 pi minus the 1 over pi plus the 2 pi ln pi plus a 0. Simplify them together. So you can see that this and this and this, they all can join together. So you will get this one as the 3 over 2 pi. Then for this, we shall combine them together by applying the law of logarithm. You have a 2 over pi and then ln half. So we need to combine them as a fractions. Okay, so I will have a 3 over 4 pi plus the 1 over ln half over pi. But ln half actually is a negative ln 2. Okay, we can make it become negative ln 2. So that when we combine together, you will get 4 ln 2 over 4 pi. Shown. That is the answer for the question number 5b. Now we move on to the question number 6. Line L1 and L2 are given as the equations over here. So maybe I can use two different color. L2 is this, respectively. The plane pi 1 contain L1 and the point P with the position vector negative 2i minus 2j plus 4k. Find the equations of pi 1, giving your answer in the vector equation form. So what you need to do is to find the directional vector, two directional vector of the B and C. Okay. So what you can do is that, so we know that the pi 1 is contain L1. Okay, so L1, it has the directional vector of this. Okay, so it will belong to the B here. Then we have another point P. And let's say there's a point here. This is the point. We call this point, let's say OA. So the A is here. So you can connect the B with the A. So you have a AB. Then you will have the directional vector for the C. So what you can do over here is, first of all, we let this one call the point A. Negative 1, negative 2, 1. And OP, this is the OP. Negative 2, negative 2, and 4. Then we find the AP. AP is a B minus A. So B minus the A, it will be a negative 1, 0, and 3. Okay, so your directional vector, vector equation of pi, it will be R equals to a position vector plus the lambda plus the mu. So this vector, I will put it here, negative 1, 0, 3. And this one, I will use this directional vector for the line L1 will be a 2, negative 3, 0. Okay, then this one, it will be either point A or point B also can. So over here, I use a point B. Okay, done. So this will be the answer for the number 6A, number 6A. So now you go for 6B, we have a pi 2, contain L2, and parallel to L1. Okay. So it's the pi 2 contain L2 and is parallel to L1. So maybe the L2 I draw it like this. So you can see that if you cross the directional vector for L1 and L2, then you will get the normal vector for the plane pi 2. So you just need to take the directional vector for the L1. Directional vector for the L1 is a 2, negative 3, 0. Directional vector for L2 is a 3, negative 1, 3. Cross product, you will get negative 6i minus the 6j plus the 7k. Okay, that is your directional vector, normal vector for the plane pi 2. So your Cartesian equations for the plane pi 2 will be the R dot with the normal vector equals to a position vector. So this position vector, I will choose the point that in the L2. L2, the point is 3, 0, -2. 3, 0, -2. -9, -6, 7, you get a -9x minus 6y plus the 7z is equals to the -41. We make the x positive, then you can make it become this. That is the answer for number 6b. Now move on, we have a 6c. We want to find the angle between of pi1 and pi2. So we need to have a n1 dot with the n2. Then modulus magnitude n1, magnitude n2, cos theta. We need to use this formula. But we already have n2, which is in the part B. Now we just need to have an n1. We don't have n1 yet. So how do you find n1? To find n1, you just need to take the cross product. Just go back to the A. So n1 is these two vector. You cross together to get the n1. 2, -3, 0. And -1, 0, 3. So if you cross product, you will get -9i minus a 6j. Then minus 3. But they actually can factorize the -3 out. Then you can get this one as a 3, 2, 1. So we will make our n1. So this one I erase. This will not be my n1. I will make my n1 is equals to 3, 2, 1. That will be easier for me. So to find the angle between the plane pi1 and plane pi2, we apply this formula, dot product formula. Modulus, because they are looking for acute angle. So this one is a 3, 2, 1. It will be a 9 plus 4 plus 1. What is your n2? N2 just now is -9, -6, and 7. -9, -6, and 7. So it will be 81 plus the 36 plus the 42. So your cos theta will be the plus -27 minus the 12 plus the 7 divided by square root of 14 and square root of 166. Press the calculator, then you get the answer as 48.4 degrees. Done. This will be the answer for the question number 6C. Now move on, we have a 6D. So now they are telling you that we have a point Q such that the OQ is equal to -5 OP. So OQ is equal to the -5 OP, which is a -5 OP is a -2, -2, 4. That means you will get this one as a 10, 10, and 20, -20. Okay, so we want to find the pi2 over here, and there's a Q here. We want to find the foot. We want to find this position vector. So that means we need to find this line. I call this line L3. This L3 is actually parallel to the normal number 2. Okay, and it's passed through the point Q. So L3, the vector equations of the line L3 is given as R equals to the OQ plus the lambda N2. N2 was 9, 6, -7. Okay, we can make -9, -6, and Make it like this. Okay, so just now I found is -9, -6, and 7, right? I want to make more positive. So I make it become 96, -7. 96, -7. That is my N2. Okay. So you combine them together, then it will become 10 plus 9 lambda, 10 plus 6 lambda, and -20 minus 7 lambda. That is my equation 1. And for the pi 2, just now pi 2 is 9x plus the 6y minus the 7z is equal to the 41. That will be your equation number 2. Just 1 into 2 substitutions. You will get 9 multiplied 10 plus 9 lambda plus the 6 multiplied 10 plus 6 lambda minus a 7 multiplied -20 minus 7 lambda is equal to the 41. Expand, press the calculator, you get 90 plus 81 lambda plus 60 plus 36 lambda plus 140 plus a 49 lambda is equal to 41. Okay, then at the end you get 166 lambda is equal to the -249. Then your lambda will be -3/2. So therefore, your OF, okay, this is the OF, this is the OF, the foot. So it will be, just replace the lambda, all the lambda over here, just change it to become -3/2. And you press a calculator, then you will get -7/2, a 1, and -19/2. Done. This will be the answer for the question number 60. And moving on, we have a question number 7. The curve C that has an equation like this, we want to find the asymptote of the C. So we start from the vertical asymptote. We just let the denominator equal to 0. Then we try to solve the quadratic equations. We cannot factorize it. Then we need to use the quadratic formula. Then this is x equals to the 1 plus Z5/2. And x is equals to the 1 minus Z5/2. That is your vertical asymptote. And as for your horizontal asymptote, you need to put the limit of x approach to infinity. X squared minus x minus 3 divided by 1 plus x minus x squared. That will give you y equal to -1. That will be your horizontal asymptote. So done for the part A. Now we move on to the part B. We want to find the stationary point. So we have to do the dy dx. So the dy dx is you keep the top, differentiate the bottom. The bottom is 1 minus the 2x plus a minus, keep the top, differentiate the bottom. Differentiate the bottom, then you will get keep the bottom, differentiate the top. Oh, sorry, I make a mistake. Keep the top, differentiate the bottom. Differentiate the bottom. Keep the bottom, differentiate the top. Minus keep the top, differentiate the bottom. Then you get this. So you have a 1 plus x minus the x square. And you can see that this, we can actually factorize it out. 2x minus 1. So it will be 1 plus x minus the x square. And then plus with the x square minus the x minus 3. simplify it, cancel, 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 then you get this one as a -2. dy dx equal to 0. That means your x is a half. And when the x is equal to half, what is your y? Just use your calculator, you get your y is a -13/5. So you found the stationary point, only one. Which is a half and -13/5. So now move on. We want to sketch a graph stating the coordinates of the intersections with the axis. So we just need to find the intercept. When x equal to 0, that means your y will be a -3 divided by 1 is a -3. And when the y is equal to 0, that means your numerator is equal to 0. So this one, it will be also cannot factorize it. So we need to use the quadratic formula. So you have a quadratic formula, and you get x equal to the 1 plus minus 13 divided by 2. Okay. So you need to be careful because the value is not a nice value. So we need to roughly know where the location is in order to sketch a graph. So now we can sketch a graph. These are the intercept. Points of the intercept. They are 0, -3, 1 plus 13/2, 0, and 1 minus 13, 0, divide 2. So we just plot the graph. I'm using freehand, so my graph may not look very nice. So you have an x here, you have a 0 here. So you are having a 0, -3. This is a -3. 0, -3. Then what is your stationary point? X is a half and -13/5. -13/5. Maybe -13/5. This is a -3. This is the half. Then vertical asymptote. 1 plus 5/2. Then 1 minus 5/2. Okay. Then -1. Horizontal asymptote. So your graph will be like this. Then this will be your this point will be 1 plus 13 divided by 2. This point will be 1 minus 13 divided by 2. That is your y. Okay, so this will be the graph for the number 7C. 7C. Yeah. Now we move on. 7D, we want to sketch the graph of a modulus. So sketch a graph of a modulus, that means everything that you have over here all need to be reflected. So if you draw again, your graph will look something like this. So you have a half over here. You have a 1 over here. Then you have a 3 over here. You have 13. So this will be your 1 plus 5 over 2. Okay. Then this will be 1 minus z 5 over 2. This is your vertical asymptote. So your graph will be like this. Then this will be your left-hand branch. This is a 1 plus 13 divided by 2. And this will be your right-hand branch. Okay, so this will be 1 minus 13 divided by 2. So now we are looking for the inequality that less than 3. So 3 is over here. Okay, less than 3 means we are looking for the graph that is below the line. Below the line. So we need to find the intersections. 4 values over here to be found. Okay. So we just need to let them equal modulus of we need to solve the inequality, make it become equal first. So we have to make it become x squared minus x minus 3 divided by 1 plus x minus x squared equal to 3. So we will have 1 is a positive 3. Another one is negative 3. So for the one with the positive 3, you need to expand 3 plus 3x minus the 3x squared. Then you will get 4x squared minus 4x minus a 6 equal to 0. Divide everyone by 2. Then you get the x is equal to the 2 plus minus square root of 28 over 4. You can make it become 1 square root of 7 divided by 2. Then this one is negative 3. Negative 3 minus 3x plus the 3x squared. Over here, you will get 2x squared minus a 2x equal to 0. Factorize the 2x out. You get the x is equal to 0, x is equal to 1. So from here, if you arrange them, you can see arrange them in a sequence. You can see that the sequence will be like this. You get this sequence, which means that this point is 1 minus 7 over 2. This is a 0. This is a 1. Then this is a 1 plus 7 over 2. So your answer will be here, between this and here. That is your answer. So just say that from the graph, your answer will be x less than 1 minus 7 over 2, 0 and 1, and the x greater than 1 plus 7 over 2. Okay, so that will be your answer. And this one no need to show. We can erase it. Erase it, erase it, erase it. This one also erase. This one also erase. This one also erase. Okay, So this will be the answer for the 6D. This one also no need to show. This one also no need to show. You can erase it. And therefore, your answer will be this. So this will be the last question for this paper. I'll stop the video. I'll see you next time. Bye-bye.